All right, let's get into it. Today, we're going from blueprint to building. We're going to pull back the curtain on the digital world and really see how all the software that, basically runs our lives is actually put together.
I mean, think about it for a second. You tap an icon on your phone, and this whole world of functionality just opens up. But how does that actually happen? It's not magic, not at all. It's a craft. And you might be surprised to hear it has a lot more in common with building a house than you'd think.
So let's dive right into our big idea here. Building software is a lot like building a house. Seriously, you would never, ever start laying bricks without a solid plan, right? Well, in software, that plan, that blueprint, is called architectural design. And the actual construction, that's the coding. This simple metaphor, it's going to be our guide through this whole thing.
Okay, so every good project, every sturdy building, it starts with the blueprint. In the software world, we call this the high-level design. This is the big picture, the master plan for the entire structure, and it's decided way before a single line of code is ever written.
A really key concept right at this stage is something called abstraction. The best way to think about it is like this. When you're designing that house blueprint, you first decide you need a kitchen. You don't start by picking out the exact model of the oven or the brand of the faucet. You just establish the need for a place to cook. That's abstraction. You're focusing on the what before you get totally lost in the how.
And this leads us directly to architecture. So, if abstraction is about deciding on the rooms you need, a kitchen, a bathroom, 2 bedrooms, then architecture is the master floor plan that connects them all. It defines how the kitchen flows into the dining room, where the hallways go, how everything fits together. It's the overall structure of your software house. We've got our floor plan, it's looking good. Now it's time to zoom in and start designing each individual room. In software, this is called component-level design. And this is where the details really start to matter.
So, to design a good room, or a good software module, you've got to follow one golden rule with 2 parts. First, you want what's called low coupling. This just means your kitchen shouldn't be structurally dependent on your bedroom. You should be able to renovate one without the other one caving in. Makes sense, right? And second, you want high cohesion. This means everything inside the kitchen, the sink, the stove, the fridge, it's all there for one single clear purpose, cooking. Everything in that room belongs together.
And let me tell you, the source material is crystal clear about the dangers of getting this wrong. There's a specific type of bad design called content coupling, where one part of the software can just reach in and mess with the internal workings of another. The verdict? It is the absolute worst way to build things. And it's a recipe for disaster, because a tiny change in one spot can unpredictably break something totally unrelated somewhere else, making the whole system just fragile and a complete nightmare to fix later on.
Just think of these bad design patterns as architectural nightmares in our house. Common coupling, that's like having a single shared water tank for the whole neighborhood. If it breaks, everybody's got a huge problem. And that worst one we just talked about, content coupling? Aw man, that's like having the plumbing for the upstairs bathroom run directly through your kitchen oven. It's messy, it's dangerous, and it makes any future repairs a total disaster. Okay, deep breath. Our internal structure is solid, the plumbing isn't running through the oven. Now let's talk about the part everyone actually sees and uses, the facade. In software, we call this the user interface, or UI. The UI is this absolutely crucial bridge between all that complex internal wiring and the person just trying to use the thing. In our house metaphor, this is all the interior design. It's the doorknobs, the light switches, the layout of the furniture. It's what transforms a cold structure into a warm, livable home. And there are really 2 main ways to design this interaction. On one hand, you have the command line interface, or CLI. This is kind of like needing to know a specific magic word to turn on the lights. It's incredibly powerful, but only if you already know the secret language. Then you have the graphical user interface, or GUI, which is what most of us use every single day. That's the light switch on the wall. It's intuitive, it's visual, and pretty much anyone can figure it out. So, we have our blueprint, we've designed all the rooms, we've even planned the interior decor. It is finally time to start construction. It's time to actually write the code. And just like real construction, there are building codes you have to follow. And these aren't just, suggestions. They make sure the software is stable, safe, and easy for someone else to work on later.
Naming things clearly, like calling a variable sales tax instead of just ST, that's like properly labeling your circuit breakers. Using verbs for functions, like add marks, tells you exactly what a tool does. And adding comments, that's not for stating the obvious like this is a support beam, it's for explaining why you needed to use such a weirdly shaped beam in that specific spot.
Wow, we've come a long way, haven't we? All the way from a simple idea to a finished product. So let's bring it all home and recap what it really takes to build software that lasts.
So what are the big takeaways from our build today? Number 1, great software starts with a great blueprint. The design always comes before you start laying bricks. Number 2, those well-designed rooms are self-contained and have a clear purpose. That's our golden rule of low coupling and high cohesion. Third, the user interface is what makes the house a home. It's that critical link to the person using it. And finally, those coding guidelines, they're the non-negotiable building codes that prevent the whole thing from falling down.
So here's a final thought for you. The next time you open up your favorite app, try to look a little closer. Look past the pretty colors and buttons. Ask yourself, what might the blueprint for this look like? How do these different rooms seem to work together? See if you can spot the signs of a really well-crafted plan behind the building. Thanks for sticking with me.